Hello again. Now I'm going to show you how to solve equations both algebraically or with the mobile or diagram that we practiced with before. So when I look at my equation, 5 plus a number x is equal to 9. I know that I need to solve for my missing variable x, keeping in mind that whatever is on the left side of my equation will be represented on the left side of my mobile, and whatever on the right side of my equation will be represented on the right side. So we're going to first start with the value of 5. So I'm going to go ahead and drag 5 ones over to the left side of my mobile. And then I also have the value of x. So I'm going to drag this over here, and I'm going to label it with the value of x. On the right side of my equation, I have 9, so I have to drag 9 separate ones to the right side to ensure that my mobile is equivalent on both sides. Always double check to make sure you've counted correctly. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now to figure out what the value of this missing x is, I know that I can take numbers away from both sides to ensure that it stays equivalent. So I'm going to go ahead and cancel out some numbers on both sides. If I cancel out a 1 on this side, I have to cancel out a 1 on this side as well. Cancel out a 1 on the left side, cancel out a 1 on the right side, and continue canceling out evenly to maintain the balance of the mobile. Now that there's no more 1s to cancel out over here, I know that this missing value of x has to be equal to what's left over on the right side. So I can tell that the value of x is equal to 1, 2, 3, 4. And if I substitute that back into my equation, it should be true. So if I start with my equation, 5 plus the value of x is equal to 9. And I'm thinking that the value of x is equal to 4, so I'm going to substitute in 4. And now I'm going to simplify the left side of my equation. So 5 plus 4 is 9, and 9 does equal 9. So I know that my equation is true. The value of 4 makes my equation true. Let's go ahead and try another one. In this equation, we have a different mathematical operation. It says 15 equals 3m. When there is no operation symbol, no addition, subtraction, multiplication, or division symbol shown, and the coefficient and the variable are squished together, I know that that actually means multiplication. So I always put a little dot there to remind me that that is multiplication. So on the left side of my mobile, I know that I need 15. So I'm going to drag 15 over on this side. It's a lot, but it's going to help us keep our hanger balanced. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So they're all hanging out over there. And on the right side of my equation, or on the right side of my mobile, I'm going to put 3 times m. What that means is that I could have 3 m's added together, or one value of m multiplied 3 times, but in the end I still have 3 m's. So I'm going to drag my 3 boxes so that I can fill them in with my missing variable x. Or in this case m, I'm sorry, keeping in mind that variables can always change, but not within the same problem. So now I need to figure out, how am I going to split up all of these 15 ones into 3 separate groups? I don't have any ones over here to cancel out on both sides, but I know that there's 15 over here and 3 m's on this side, which means I need to split these 15 ones into 3 equal groups. So if I have 15, this is very similar to a division problem. So 15 divided by the 3 m's is equal to 5. So I'm going to go ahead and say this 1m will match up with 5 ones. The second m will match up with the second set of 5 ones. And the third m will match up with the third set of 5 ones. If it works out evenly, then I know that my answer is correct. So keeping in mind down here, we know that we just did a division problem, which is actually the opposite of multiplication. So sometimes students will show their work and say 3 times m, the inverse operation would be division. So if I divide this side by 3, knowing that a fraction bar means division, I can also divide the other side of my equation or my balance by 3. So if I divide this by 3, 15 divided by 3 is equal to 5. And 3 divided by 3 is actually 1m. But 1 times anything is itself, so 5 is actually equal to m. Isn't that the same answer that we just got? One of these m's matched up with 5 separate ones. All right, last one here. Solving equations now when we have the variable written multiple times. So this one's a little bit different. Let's take it step by step. On the left side here, it says we have 2 times p plus another p equals 10 plus p. So I know that I need to drag 2 p's, 2 times p, plus 1 more p on the left side. So I'm going to go ahead and label those guys p, p, and p. So I have 3 p variables on the left side. On the right side, I have the value of 10. So I need to go ahead and drag my 10 ones over. And then I also need to add on 1 more variable, p. So I'm going to label that the variable p. Double check that I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, I almost forgot one. You have to be very careful. So I'm going to add 1 more right here. Now, if I want to cancel something out on both sides, is there something that I could take away from both sides of my balance? I see that I have a p on this side and a p on this side. So if I take a p away over here and a p away on the other side, my balance should still be equivalent. Now I know that I have 2 p's left. So 2p has to be equal to what is left over on the right side, which was 10. Which means I need to split the right side up into 2 equal groups because I need to split the ones equally between the 2 p's. So 10 divided by the 2 p's is equal to 5. Let's go ahead and circle that to see if it works. This 1p is going to go with the first 5, and this second p will go with the second 5, and it works out evenly. The way to look at the equation and solve this is to say, what could I take away from both sides? I see a positive p over here and a positive p over here, so I can eliminate both of those. Then I have my equation 2p equals 10. 2 times p equals 10. The inverse operation of multiplication is division. So I needed to divide both sides of my mobile by 2. Divide by 2. 2 divided by 2 is 1p, which equals 10 divided by 2, which is 5. But 1 times anything is itself, so p just simply equals 5, which is the same answer that we had in our mobile. So you can see that there's always 2 ways to solve.